Okay, welcome to the next tutorial. This is on making decisions. We're going to look at the if statement. Okay, before we begin, we know that the data types in C, we've already reviewed those, are int. We have char, which is obviously an int type. It's an 8-bit, int being 16-bit. And we have two floating point data types. One is float and one is double. So there is no Boolean data type in C. However, there are Boolean expressions that return true or false, but they don't really return true or false. They return integers that represent true or false. So it's not like Java where you actually have Boolean data types. When C returns those integer values in Boolean, it returns it as a 0 or a non-zero value. So in this example, we have x being an integer type that's assigned 5. We have y and z. So this first statement expression here, okay, we evaluate this expression in the middle, which says, okay, is x greater than 4? Yes, it is, because x is equal to 5. So it's going to return a 1, which then is assigned to y. Likewise, the next expression that we have here is that it has to be false, because 5 is obviously not greater than 6. So we're going to return a 0. The if statement looks simply like this: if, and then the expression in the middle, and then the statement. So the expression is evaluated for that true or false. Okay, if it's true, the statement's executed, and that statement can represent one statement expression, or in the case here that you see, it can have a compound statement, or represent, if it's only one statement expression, it doesn't need parentheses. So we'll see some examples. So here's our flowchart. We start here. If the expression is evaluated to be true, then the statement or compound statements or group of statements that you have then are executed. If it's not true, then it's false, and we go right past to the end of that statement. So here's an example. X is assigned a value of 5, and we have here if x. Well, x is equal to 5, so is x a 0 value or a non-zero value? Well, it's a non-zero value, so therefore it's true. So we will print x is equal to 5. That's all this little string code means. So we'll say x equals to 5 because it's true. Next example, well, what will happen if we if we assign a value of 0 to x? Well, x is a 0, then therefore it's a 0 value, therefore it must be false. So if this is false, then nothing gets printed. And then finally, if x is assigned a value of minus 82, well, minus 82 is a non-zero value. Therefore, this statement is true, and it will print x is equal to minus 82. Nested if statements are very, very useful if we want to string along a lot of statements and expressions that we want to all be true. So if you look at this example, we've got community hours, courses, and average with different data types here. And what this statement is saying is that if community hours are greater than or equal to 40, here's our relational operator. If that's true, well, let's look at this. We've assigned a value of 40 to that. Well, that's true because it falls within 40 or greater than. So we go to the next statement, and this expression is evaluated. And that expression, is that true or false? Well, courses are 31.5. So yes, if courses are greater than or equal to 30, which is true, then we fall down to the next statement. And then this one has two expressions that are attached with this logical operator. So therefore, this logical operator being AND means that both of these have to be true. So if average is greater than or equal to 90 and it's less than or equal to 100, well, it's in between those amounts at 92.36. So this is definitely true and true. Therefore, we can print you got accepted to Waterloo. Okay, notice also here within this statement for this if statement here, this is your statement expression. There is no curly braces because there is only one statement expression. We don't need to add curly braces. If there's more than one, we do need to add those curly braces because it turns into a compound statement. Here's the if else. So the if is or the if else is the same as the if, except we're adding this else here, which adds one more statement. So if the expression is evaluated for Boolean true or false, this first one, okay, if it's true, statement 1 is executed. If it's not, then it must be evaluated as statement 2. Okay, so it's a default statement. So that would be like saying, well, are you awake? Well, if you are awake, then execute statement 1. If you're not awake, well, then you must be asleep. So execute statement 2. Here is our flow chart. So again, we're going back to this expression being evaluated. If it's true, we execute statement 1, and then we're out. False, we automatically execute statement 2 without even, notice there's no conditional expression here. It's just that if this is true, execute that. If it's false, execute that. Okay, here's an example. So float, we're going to assign this mark, which is a float type, to be 75.5, which is my midterm mark. And I'm going to say here, well, if my mark is less than 0 or my mark is greater than 100. So only one of these expressions must be true. Remember an OR gate, or both, for this whole thing to be true. So is it true or is it false? Well, 75.5 is not less than 0 and it is not greater than 100. So that would be false. And because that's false, it's going to automatically print that it's a valid mark. And really what we're saying is that it's greater than or equal to 0 and less than or equal to 100. But if it was less than 0 or greater than 100, we would be printing this invalid mark. So there you see a very useful way of combining these relational operators with logical operators. You'll see that a lot in your code. This is the if-else-if statement. So if expression 1 is evaluated for true, okay, if it's true, then statement 1 is executed. And if it's false, then expression 2 is evaluated. And if that expression 2 is true, then statement 2 is executed. Otherwise, if both expression 1 and expression 2 are false, then by default, this statement 3 is executed. Here's our flow chart. Expression 1 we see, if it's true, statement 1 is executed, and then it goes right to the end. We don't go on to checking expression 2 if the first one is true. If it's false, however, then we can check to see if expression 2 is true or false. If it is true, then we execute statement 2. And then we go right past statement 3 there. And then if both of these are false, then by default we execute statement 3. So here's an example here. If I had a mark between, let's say, greater than or equal to 50 and less than 60, then I would have a level 1. Else if my mark was in between 60 and less than 70, that would have a level 2. If it was greater than or equal to 70 and less than 80, we would have a level 3. And then if it's greater than or equal to 80 and less than or equal to 100, we'd have a level 4. Now assuming I had a mark that was in between 0 and 100, if none of these conditions were satisfied, then by default I would have to have a mark that was less than 50 but greater than or equal to 0. Therefore, I'd have a level R. So that else is very useful because it just means everything else but these conditions here. And again, I've combined nicely these operators with relational and logical operators. This is the type of example you're going to see in MPLAB X. So first off, we're going to teach all of port B to be outputs. We're going to initialize all those ports to be 0. And then we're immediately going to use this port A register to read from, because we have two buttons here, one attached to RE0, one attached to RE1. Now assuming that when we push the button, it grounds the button, okay, so when it's not pushed, it's a 1, then we're saying here that if RE0 is pushed and RE1 is not, then turn on LED RB0. Else if RA1 is pushed and RA0 is not, then turn on LED RB1. Else if are both pressed, then turn on RB2. Now, if none of those are satisfied, then it must be that we're not pressing either of them. And in that instance, we're just saying, by example here, turn on all the LEDs. Okay, so that concludes our discussion on decision-making structures with the if statement.